Professor Hirschbalin in last class talked about the emerging post-Newtonian paradigm known as complexity theory. Now, this is difficult stuff, and think back of Nietzsche, who a few slides ago was quoted to say that the things we tend to feel are most true are simply the things we are most used to. What we are most used to in this context is still the Newtonian paradigm. So, in other words, the paradigm that this new post-Newtonian paradigm is replacing, or at least adding to. What is this Newtonian paradigm? We're all very familiar with it, even if the 3 laws of motion from Newton are not ready to mind. The fact is that apparently many interesting phenomena that we are dealing with today cannot be explained with this old paradigm, and yet the old paradigm persists because, again, we are so very used to it, and therefore it feels so very true. Now, again, as you know from last class, from Wednesday's class, we are pattern seekers because patterns provide stability in the law, but also in the sciences and in all different aspects of our lives. Patterns provide stability and help us live together, build trust, set up systems to deal with unexpected situations, etc. Now, our favorite pattern, the one we're most fond of discerning in reality, or what we think is reality, is cause and effect. We just really like to explain things in terms of the things that cause them. We like to draw arrows and says, if P, then Q. What is the risk that was pointed out in last Wednesday's class, the risk of conservatism? Well, rigidity is an obstacle to adaptability. How does that apply here? If we try to see everything in terms of cause and effect, we might, on the one hand, overlook phenomena that don't fit in this pattern, and on the other hand, we might misexplain or misinterpret phenomena that simply do not allow for that mold, that simply do not allow for that pattern. That tool, the cause and effect tool, simply does not work for certain things. This is why we need complexity theory. So what more can we say about our favorite pattern, cause and effect? So first of all, it's again very important to note how very fond we are of cause and effect. We like to see cause and effect relations everywhere, even if we cannot prove them. Again, think of personal experience. When you got into a bad situation, you tried to figure out how it happened and how you could prevent this from happening in the future. What you do is you look for causes. Why did I do that? How did I end up here? And then you hope that keeping those causes in mind, you might avoid them in the future so that the corresponding effects also will not occur. Our fondness of cause and effect leads us to what are known as spurious correlations. And here is one that I already showed you last week as well. The divorce rate in Maine is correlated to the per capita consumption of margarine. Now this suggests, but it's of course not true, that margarine consumption actually has an effect on the divorce rate. In other words, if you want to make sure not to get a divorce, watch your margarine intake. Now this is plainly silly. Everybody knows that divorce rates are not correlated to margarine consumption. And yet, with the large data sets we have at hand nowadays, we can find a lot of these sort of neat-looking correlations, or at least sell them as correlations, depending on the context. We are very willing to believe that if there is a pattern of some kind, that pattern is explained by cause and effect, that two events are actually related. And again, think of your own personal experience. You might be superstitious and think that if you do bad on a test, it's because you weren't wearing your lucky sweater, say. You see it in sports games all the time. People wearing certain jerseys, their lucky number, all kinds of rituals that we think can influence the course of reality. We believe in cause and effect, both because it seems to actually hold. It's a pattern that we see everywhere, we witness everywhere in nature, in reality. But at the same time, we're also aware of the fact that we often see cause and effect relationships where they might not exist at all, or where at the very least they're not proven to exist. Had this coronavirus outbreak happened hundreds of years ago, or maybe not even hundreds of years ago, but 100 years ago, people might have said, well, this is happening as some kind of punishment from God. What explains what is happening now? Well, we are sinful and we are now punished for it by this disease. For a long time, people thought, therefore, that prayer was a good solution to, or a good cause, a good remedy for disease. Now, you may still want to pray, but most of us recognize that faith kind of exists in a different area of our lives than science. So though we might want to pray, we also want to find a vaccine that can counter this virus. Cause and effect appear to be very real, but we also know from our own experience that we tend to attribute cause and effects to situations where it is unproven. David Hume wrote about the problematic aspects of our thinking in terms of causes and effects a long time ago. He writes the following sentence: "Present an object to a person whose skill and intelligence are as great as you like. If the object is of a kind that is entirely new to him, no amount of studying of its perceptible qualities will enable him to discover any of its causes or effects." What Hume is saying here, in short, is that cause and effect relationships can be derived only from experience, never from thinking alone. In fact, just thinking about stuff delivers very little truth or knowledge. Just thinking is helpful in cases of, for example, geometry. We might think about circles, and it's enough to just have them in our head and consider them there, if in fact we are capable of such abstract thought. The vast majority of our bits and pieces of knowledge is derived from experience. Take, for example, a magnet. According to the sentence I just read, we cannot derive any of the causes or effects from just looking at this magnet. We'd have to experiment with it in order to know that it attracts metal, for example. There's nothing about this magnet itself that would let you know that it has this capacity. In other words, if you have never seen a magnet at work, you've never heard about magnets, you've never seen them in operation, then when confronted with this thing, you would not know it is a magnet. Not only would you not know its name, you also wouldn't know its properties. Now this perhaps we take for granted. This is fairly obvious. Of course, we understand that we have to be aware of the existence of magnets and what they do before we could make a claim like, hey, this is a magnet, therefore it attracts metal. But it gets more complicated than that. You no doubt noticed that today is Friday the 13th. Now say that we had met on campus today, and say that then tonight you had a bad case of the sniffles. You might think, see, I know we shouldn't have had class on campus because it is Friday the 13th and now I have the virus. Is there a cause and effect relationship? Well, the trouble is it's really hard to prove that there is not. It doesn't seem very scientific, but it's definitely possible. Not sure it is probable, but again, cause and effect relationships, part of their appeal lies in the fact that a cause and effect relationship is often very hard to disprove in cases such as this. If you had had a cold at the end of a day that you went to class on campus when really you'd rather not have gone, you could attribute it to the fact that it was Friday the 13th, say that was the cause of my getting sick.